in this lab, we'll do a standardization of a sodium hydroxide. In this lab, the objective is to determine the concentration of standard sodium hydroxide solution by titration. So here's a question. Can you make sodium hydroxide solution just by weighing solid sodium hydroxide and dilute that into DI water? Then would you can weigh certain amount of sodium hydroxide and you can calculate the moles and you know the volume of the water and you can determine the concentration that way, right? Why can you do that? So in this case, we are not just measuring the sodium hydroxide weight, dilute that into a certain amount of water. In this case, we weigh out, certainly we'll weigh out some sodium hydroxide and we get the approximate concentration. And then we use other chemical to titrate this sodium hydroxide solution to get the precise concentration of the sodium hydroxide. What would happen if I just dilute sodium hydroxide into water? Usually what happens is once the water is in air, remember when we breathe in, breathe out, there's a carbon dioxide in air, right? Carbon dioxide can be dissolved in water. And that carbon dioxide can react with sodium hydroxide. So when that happens, if you weigh some sodium hydroxide and dilute that into water, and the concentration is not the same as you calculated because the sodium hydroxide will be consumed by the carbon dioxide dissolved in that water. And that's very difficult to predict how much is consumed because depending on the temperature, depending on the pressure on that particular day, the amount of carbon hydroxide dissolved in water can be different. So it's difficult to predict how much is consumed. We usually just make a rough kind of approximate concentration to 0.1 molar here, and then we use other chemicals. In this experiment, we use a KHP to titrate sodium hydroxide. In this experiment, you will calculate the concentration of the sodium hydroxide through the other chemical. It's a potassium hydrogen phthalate, or we can call that KHP. It's one of the common primary standards for sodium hydroxide standardization. And the chemical reaction is this one. So the hydrogen phthalic acid anion react with hydroxide anion and forms water and this phthalate anion. So 1 mole of KHP react with 1 mole of sodium hydroxide. Once we have this quantitative relationship and we know how much KHP we have in the solution, we can calculate the mole of KHP. And once we know the volume of sodium hydroxide that's titrated, then we can calculate the concentration of sodium hydroxide. Okay, so based on that reaction, we can see the mole of KHP equals the mole of sodium hydroxide, right? And the mole of sodium hydroxide also equal to the molarity of sodium hydroxide times the volume of sodium hydroxide. So in this process, we need to know the exact volume of sodium hydroxide. So based on the moles of KHP, we can calculate the molarity of sodium hydroxide. And in this case, we weigh some KHP into this flask and add a little bit of water to have that dissolved in water. And then we use a burette to titrate the sodium hydroxide. The burette has a very precise reading of volume. So once we know the volume, we can calculate the molarity of sodium hydroxide. In this experiment, precision is very important. Precision here means reproductivity, or meaning every time would you have the similar result or not. That's measured by relative standard deviation. This is how we calculate standard deviation. Say we have 3 measurements. Each measurement they have xi value, and the average as x bar there. We can calculate the difference, the square of the difference between each measurement and its average, and divided by n-1, and here is a number of the measurement. So here, if we have 3 measurements, then n equal to 3, and n-1 is 2. So sum up all the difference square and divide by 2. That's the standard deviation. And once we have the standard deviation, we divided that by the average. That'll give us relative standard deviation. And you will report a relative standard deviation in the unit of parts per thousand. And the smaller value you got, the better precision. In order to do this experiment, there are 3 steps. First is weighing out the KHP, and second, conditioning the burette, and then titrating. First step is weighing out the KHP. The KHP is hygroscopic, so it must be kept dry in a dry condition. And we use 200 gram analytical balance to measure the weight of KHP. We will measure about half a gram of KHP. And once we measure that, the second step is to condition the burette. I have a video posted on Canvas. So we just saw this one, titration of the sodium hydroxide with the KHP, conditioning, and the titrating. Okay, so when at acidic conditions, the solution should be clear, and when it's a basic, it should be pink, and the one it's at the end point that you just saw in the video, it should be very light pink. Okay. So in this case, we're starting the burette from 0.6 mil, and then ending point is 25.0, and then we take the difference and keep 4 significant figures, and the volume of sodium hydroxide used is 24.40 mil. Okay, take the difference, the starting point and ending point, and we know each time how much KHP is used, and we can calculate the molecular weight of the KHP, and based on the gram of KHP, we can calculate the mole of KHP, right? When we have the mole of KHP, we also know the volume of sodium hydroxide. And based on the reaction, the quantitative relationship between KHP and sodium hydroxide, we can calculate the molarity of a sodium hydroxide solution. So it's same stuff is provided. It's an experimental procedural, so you can follow what's down in the lab. And there will all be a lab template, just same as before, with the tables and listed the volumes of sodium hydroxide used, and also the mass grams of KHP used for each titration. So what you need to do, download the lab report template that contains the titration data, calculate the molarity for each titration, and then calculate the average molarity, and then calculate the relative standard deviation in units of parts per thousand, and do an error analysis, and there will be some questions to answer. Okay, everything needs to be typed except calculations can be done by hand and uploaded.